We now come to this example 4, and there are two versions. So this is version 1. Now the diagram has spoken for itself. Okay, so it's a uniform rod of mass 1 kg and length 2 meters, and that's a string. So A, we are required to find the tension in the string. So in this first version, we take moment about the hinge. So the tension is providing the anti-clockwise moment. So we apply the moment of a force is equal to the force F D, which is 2 meter times sine theta times sine 40 degrees. And then the 9 kg force having a weight of 19 Newton is providing a moment of 90 times 1.2. So we get the tension is about 84 newtons. Okay, in part B, the force exerted at the hinge by the wall. So let's look at part B. Now we resolve the hinge force into two components. One is horizontal component, R cosine theta. The other is R sine theta. And then the tension can be resolved into two components, R T times sine 40 degrees, T times cosine 40 degrees. So horizontally, R cosine theta is equal to T cosine 40 degrees. And we get at 64.35 something. Now vertically, the sum of the vertical forces, which is R sine theta plus T times sine 40 degrees, should be equal to the sum of the downward forces, 90. So R sine theta is 90 minus T times sine 40 degrees, and we get 36. And we get 36. So with that, we can find the R equal to the square of the component R cosine theta plus the square of R sine theta, the whole thing square root. So we get 73.7 newtons, and tangent theta is that. So the third part of the question is explain why a heavier or lighter load can be hung on the rod safely if the load is shifted to the left. So let's look at part C. So if T is too large, the string will break. So we just assume that the T maintain its value. So let W be the weight of the load and distance be the weight from the hinge. So T times 2 sine theta equal to WD. So the weight W is equal to the moment of the tension T times 2 times sine 40 degree over D. And the weight now, when the load is shifted to the left, so D decreases. So for the same T, W will be larger. So this is version 1. Now, why do I do this? Because I've done that in 4P, but this is wrong. It's very often to get wrong from this type of question, because there's one force not joined, not so obvious. This is the weight of the rod, 1 kg, so there should be 10 newtons. There should be 10 newtons acting in the center. So we'll do it in the next video.